Physics is a huge subject that covers many different topics, going from galaxy in the depth of space right down to subatomic particles. And if you don't already know, physics is difficult sometimes to see how all these different subjects are related to each other. So this is my attempt to show that in a map. So this is the map of physics. Okay, physics can be broadly broken down into three main parts: classical physics, quantum physics, and relativity. We'll start with classical physics, and a good person to start with is Isaac Newton. His laws of motion describe how everything made of matter moves about, and his law of uniform gravitation states. Together, the motion of planets in the sky with the falling of objects on Earth into an elegant and general description. He also innovates calculus as supremely powerful mathematical tool which has been used over the countries. To drive new physics, calculus is really part of mathematics, but physics and mathematics are inseparable. Math is the language of physics. You can imagine it like the bedrock. That the world of physics is built from. Newton also made stars in the field of optics, which is the physics of light and how it travels through different material. It explains refraction. See in prisms and lens, which are used to focus light in the telescope, microscope, and cameras. Telescope enables us to peer into the deep of space and observe the wide array of subjects. They all develop astrophysics and cosmology. Optics is closely related to the theory of wave, which is basically how energy can travel through disturbance of a medium like ripples on the surface of a pond or sound through the air. Light doesn't need a medium to travel through, it can travel through the vacuum of space, but it still follows the same principle as always, namely reflection, refraction, and diffraction. This leads us to electromagnetism, the description of magnets, electricity, or more generally, electric and magnetic fields. It was a physicist called James Clerk Maxwell who discovered that these are two aspects of the same thing and derive the wonderfully elegant rules of electromagnetism and theories that light was an electromagnetic wave. Electromagnetism also explains all of electricity. Jumping back a little bit, classical mechanics is related to Newton's laws and covers the property and motion of solid objects, how to move when force hit them. What happens when they are joined together, like in gears or buildings or bridge? Fluid mechanics is the description of the law of liquids and gases. Using fluid mechanics, you can work how much lift is generated from our airplane wings, how aerodynamics occurs is fluid mechanics is naturally difficult, mostly because motion of tiny things like molecules get really complicated really fast, which leads us the chaos theory. Chaos theory is the description of large complex systems and how small difference in initial condition can lead to very different final outcomes. Thermodynamics is the description of energy and how it passes from one from the another. It also includes entropy, which is a mixture of orders and disorders, and basically tells you about usable different kinds of energy are. Energy is fundamental property to physics, and although I have written energy here, I should have written it everywhere on this map because everything has energy. So that is all of classical physics. The picture of the universe we had around the year 19,000, it told us we live in the universe where everything runs sort of like clockwork. If you could measure everything accurately, now the future-wise kind of predetermined. However, not everything was solved. There were just a few of Hull in experiments that hint at something more. The orbit of Mercury was simply too fast, and some strange this happened, and the small skulls with electron and light which were all unexplained. Physics at the time thought that they would solve and explain their problems soon enough, but looking at them, they unraveled the new domains of relativity and quantum physics, and turned our understanding of the universe completely on its head. Albert Einstein was the genius who developed the theories of special and general relativity. Special relativity predicts that the speed of light is constant for all observed, which means that when you travel really fast, where stuff starts happening like time slowing down. It also states that energy and matter are different aspects of the same thing through the famous formula A.M.Si quadrat. General relativity says the space and time are part of the same fabric called space-time, and that the force of gravity comes from object bending space-time, making other objects fall in towards them. While relativity describes the very big other physics, we're busy at work on the very small in the world of quantum physics. Atomic theory problem the nature of the atom, and more detailed description of the atom were developed. From a tiny sphere to electron orbits to energy level, and then the electron being wave lecture distribution. Condensed matter physics describe the quantum physics of many atoms together. In solid and liquid is where many great technology have come from, like computer, lasers, and quantum information science. Nuclear physics describe how the nucleus of atoms behave and explain radiation, nuclear fission, the splitting of the atom used in our nuclear power, and nuclear fission, which takes place in the sun and will hopefully soon be heard here on Earth. Particle physics probe deep to find the fundamental subatomic particle that everything is made of and are described in the standard model of particle physics. Quantum field theory captures all of quantum physics and combines it with the special theory of relativity and is the best description of the universe we have. Unfortunately, quantum field theory doesn't include gravity, and so physics don't know how to join together quantum physics and the general theory of relativity, leading to the giant chasm of ignorance. One day in the future, we have to close his chasm and come out with a theory of all of physics. We call it quantum gravity, and there are many attempts to do this. Some example are string theory, or love quantum gravity, and